Hello, good afternoon. Welcome, Gdansk. Yeah, like to hear a little bit of you. So actually, I'm traveling a lot as the CTO, as you can imagine. And on one of my recent trips, I watched the movie Passenger. You can discuss the quality on your own of this movie, but there was one interesting piece that struck me. This movie was all about the spaceship that was 70 years on its way to bring people to a remote planet. But there was then an issue on the way to it because there was a CPU problem caused by a meteorite. And since the spaceship was pretty similar to a distributed computing system, like tons of microservices in it, there was a ripple effect from this one CPU all the way to the others, so that then all the other services were overloaded and the ship could not heal itself anymore. And I thought, great, what they would have needed actually is our product Dynatrace, because we would have them told exactly, oh, it was the CPU that causes this issue because we built such a dependency model in there. But the whole point is not that I give you now an advertisement of our product here. This was more the intro to actually our own story of how have we come to build the product Dynatrace in a totally new way, in a DevOps way. But for that, I give you just a quick background, what it is, what we do. Because Dynatrace actually is a monitoring solution. You see here a screenshot on there, especially for distributed applications. So our customers typically run 50 hosts. Our bigger customers run 120,000 hosts and monitor their product with Dynatrace. So it's a pretty big challenge to be solved, all the way from the end user experience to the server. But that's not an advertisement, as I said, but instead, I'm telling you the story how we got from actually building in Gdansk here and also in the Linz lab a product that was sold purely to on-premises usage. So we had 2 releases a year, nothing more. It took forever to get feedback from the customers. And how we transitioned from 2011 to 2016 to actually arrive at a SaaS solution and on-premises solution that both is released in a cadence of 26 major releases a year, and even, as of last year, 170 deployments per day. So this is a major shift considered for a lab that was used to go on-premises only. And one of the key criteria to actually make this shift happen was we knew going to a SaaS model, we know we do need continuous delivery and deployment. But this can't be enough. We need continuous delivery and feedback. Hence, we recoined the terms continuous delivery CD to CDF. And also a lesson learned for us was that actually, if you don't do continuous integration already at the good grade, it's pretty hard to get there. So if you're not there at continuous integration, master this first, because then it's easy to extend your continuous integration all the way out into production with a single unified stack. So when we set out in 2011 and said, now let's build a new generation of Dynatrace product and do it in a SaaS way, then we thought, okay, yeah, since we here in Gdansk have no idea how to do 24/7 operations, let's use our US colleagues' network operations center. They have already a follow the sun model. And in order to try that out, we took our on-premises product that we had back then and said, okay, let's try it and let it host by them. And so they did. It took just 2 months to get actually a service provisioned. Oh. And then we had a couple of customers on that to try it out, how it feels to create SaaS software. And the moment came, we had a bug that we wanted to quickly get fixed. So thanks to our great working CI from code check-in to have a fix pack, it was just in less than 24 hours we could provide that. And then we went to the NOC team, to this operations team, and said, please deploy this. We want that our customers have this tomorrow. And they said, oh, wait. We have on Thursdays our change request meeting. Okay. So, and then when you are at the meeting, we will discuss when we can deploy it. Really? So they told us it takes 3 weeks to deploy a patch into production. Come on, this can't be this way. This really sucks. So this pain really drove us to push them further. Hey guys, we have a CI that is fast, and you can't be the factor of slowing us down when it's all about customer success and their experience. So they promised to do lots of automation, build their own Puppet Chef stuff, but this would then again break the deployment pipeline, because then we would have a CI pipeline and all the way then it goes to operations team and then they have their own automation. So it's just a disaster. So all this pain actually drove us that far to say, stop it. We won't work with that team this way. We need to do a full automation. We need to have actually the ability to get from code to production in no more than 1 hour. So, and this was the goal set out and the pain that drove us, okay, let's learn everything about DevOps and continuous delivery. And here we are, as of today, here are a couple of metrics on there about the number of code commits that a team of about 250 engineers is actually doing into the master branch. You've heard about already the 26 major releases. And actually, by today, as of May, we went even to 500 deployments per day, deployments into production. And actually, another metric I'm proud of, you see on the right, there's 93% of production issues are actually found by engineers. And this is because our engineers are using our products themselves and take responsibility, and this is the most important part. For Dynatrace, the engineers have the responsibility about everything to the customer, and this was a huge culture change. So now the next section is truly about how to get there. How can you change your own culture, if you're not there yet, kind of to get to that level. So the first thing was actually to abandon QA and make sure the engineers do the testing, of course. So we had this in place, but still we suffered actually from that every engineer would demo the sprint build of his own machine. And you can imagine when an engineer demos off the machine, it always works. I think that's the common sentence when an engineer says, oh, it works on my machine, and in production it crashes. Oh. So this was a big problem, and we needed to figure out what to do about it. So what we established is, said, no longer demo off your machine, but instead demo of a production-like daily environment, daily build environment, and only demo from this totally integrated system. And this worked wonders, because actually, for 3 months, we could not get any build done because it always broke, because always there was an engineer checking in something that had a dependency on some other component. And remember, kind of, even back then it was already over 100 engineers checking in into the same code base. and the stuff broke. So it was a horror. We were close to saying, let's stop this. This doesn't work. We will never get it done. But then I also thought about how can we raise the responsibility of engineers so that they figure out, hey, we're sitting in the same boat. I can't go home on Friday afternoon, quickly checking in, and then my colleague actually has a dependency on this and can't go home on Friday because this previous check-in just messed up. And one thing that we did actually is to get the culture in place was have a visualization in the cafeteria all across the office that visualizes the state of the build pipeline. So when the engineer does his stuff, checks in and is happy, oh, I did just such cool stuff, goes to the coffee machine, and this is red up there. Oh gosh, maybe this was me. And so he runs back and checks whether it was his issue or looks at the smartphone to check whether he got the Jira ticket for that. So this was a key item also to help the cultural change to take responsibility for the engineers. And you can even 3D print those on your own because it's also just a regular IoT device. So now we have mastered the key builds all the way to pre-production quality stage. But now the common thing is that an engineer has done something, and then we throw it all the way to the operations team, and they have to then keep something running that they have no clue about because they have not built it. That has to be fixed too, right? So basically what it means then is also what we did there is we gave the architects the responsibility for production. So the chief product architect owns everything when there is something messed up in production. This means they proactively look every day into our monitoring dashboards, into log files, check about how's the performance doing, what are the new customers on our systems, to be proactive about it. And what this also means that the chief software architect and the architects team have the same say as the product managers. Because the worst what's happening classically is that the product manager is kind of always the boss and says, we need to have in the next sprint these 2 features because otherwise we don't do that and that revenue. And then the architects are always pushed away and your quality never gets up, you never scale. So this is why it's so important that the architect has the same say and the architect can say, in the next sprint we do nothing but this scalability topic or this performance topic or this security topic. So very important thing. So we mastered to do a shift left in quality, meaning kind of the engineering team is caring about all the quality aspects and you abandon the QA team. But then there's the next factor, and this means you're doing a shift right also there, and that means that the engineers now, in order to take responsibility about the production systems, need to think right at the beginning also about what metrics do I need to monitor from the production system so I do know what's going on there. And that's also a new way. And now you might think, oh gosh, so my engineer has to know about security, of course about coding, about performance, about testing. Who can learn all that and know all that? But the big key takeaway and the reason why the engineering team actually took the responsibility about the production and the features they built is because they get the real-time feedback now and see at the end of a sprint already that what they built is actually being used by the customers. Man, this makes you really proud when you know so quickly that your functionality is being adopted and liked by your customers. And this feedback is the key to success that you always need to have to change the culture. And then there's the rest of the thing, so how to operate then 24/7. The engineering team clearly said, I don't want to touch disk storage or do this kind of stuff. I don't even want to care about the public cloud and this kind of things and look at knock screens. And now you could say, those arrogant engineers, they just don't want to do the jobs actually that the great operations team is doing. But actually this mindset was super helpful for us because it drove us to say, if we don't want to build our own 24/7 team, then the only solution is total automation, right? So what we then did with this, or what happened, we actually had the plan to do DevOps. Of course, we adopted this culture and so forth, but without us actually really knowing, we ended up at no ops. And this was even a surprise to us, but super exciting. And a few also lessons learned here for you that you can take away is how to get there. Or one of those elements is looking at the run books. Because also at the very beginning when we did the first baby steps towards automation, we still thought, we have no experience in 24/7. Let's still have the network operations team look at our software, just for safety reasons. So we did. What did they ask again? Writing run books. Of course, we wrote run books in the engineering team, but what does an engineer say writing run books? I want to write code and features, not run books. Of course not. Then we looked at those run books, and if you look at those, doesn't this look already like code, this run book entry? It does. So we made a game. We said, for every sprint, we want to automate at least one of those run book entries completely and move this functionality into our orchestration system. So we did. And after 6 sprints, there was only a single run book entry left. Guess what that said? It said if the orchestration and the self-healing can't heal our software, call R&D. That's it. And this was the moment it was clear, we arrived at no ops. Fantastic. And actually today we do have for all of our customers around the globe and millions of agents connected out there, only a team of 4 people. That is the core DevOps team. And actually also they don't do operations. What they really do is the product management of the orchestration system. And you see here a screenshot to the top right, and that's also built by our great Gdansk team here that manages all of our instances in Amazon. And this cares about self-healing and manages all the global network of our instances that we have. Here's just kind of a global screen. Everything is high availability, failover, horizontal scalability is there. And the beauty is there's no one needed 24/7. The time of knock screens is finally gone. And to actually also get there, there's a prerequisite of how you architect software too. Yes, we had the pleasure to completely design the Dynatrace from scratch 2011 onwards and architect failover into it and the self-healing. But then there's one also very important method, and this is the chaos monkey test. So we intentionally kill instances in production in Amazon just to make sure to continuously also test that our self-healing works. And this is a test that you can do yourself. If you have too much fear to kill any of your instances that you have in production running, then you're clearly not there with your automation. So it's a very good test. And believe me, for a long time my team was too much afraid of, oh, you can't do this. But then also at the very beginning, very unfortunately, there was this heartbleed bug, and Amazon sent on Friday afternoon an email, oh, over the weekend we're going to bounce all your 450 instances. Of course, the DevOps manager kind of got like that. You can't do that to me. And they did. So the DevOps manager was watching exactly those previous orchestration screens, what's going on, what's happening, and everything worked out. So this was also the first big additional proof point that self-healing does work. So there's another thing. So we talked a lot about kind of culture change, technology you need with orchestration systems. But there's another important factor to be successful in the transformation towards DevOps and NoOps. And that is management buy-in. You can be the best engineering team. If management doesn't buy in that DevOps makes sense, you can only go that far and then you're stuck. I'll give you an example. It did cost us a team of 7 people for 2 years to just build the orchestration system alone. So the orchestration itself is almost a product, right? And this is an investment because managers typically would say, no, we don't have that money for building just orchestration, we want to build features. But that's the whole point. Getting to such a high grade of automation requires a heavy upfront investment and pays back later. So that's one thing that management needs to understand. The other part is, it's not just engineering, of course, who lives DevOps. It's the entire system. It's services, it's marketing, and so forth, everyone in the company. So this also needs to be understood top-down to make this all successful and to understand the value of why is it actually good to deliver software every other week. And also for us, for the team, what helped a lot is that we put the stake into the ground. Okay, we have no idea how, but what we do want is the code to production within 1 hour. The engineers and the product managers went wild. We will never get there, and this is too hard. Even the large features take so long. But the team stuck with me with that. And just every sprint, we figured how we get closer and closer to that. And honestly, it took us in total 4 years to get there. Lots of work in automation, lots of work in process changes, how the team collaborates to get there, but we got there and it totally pays off. So it is truly believe in this mission impossible. So where do we want to go next? Because yes, we're here, we have this NoOps achievement, but our customer base is growing rapidly, so we have to master that too. And that's why we look now, or we actually have started already to do voice ops and chat ops as part of the engineering team culture. This means that the teams, when they do stand-ups, they integrate also the monitoring capabilities to get proactive information about, there are key end users seeing now poor performance, or there is an double up in usage of our product for this functionality. To also flip actually from a need to check out how the systems are doing to actually getting the information proactively from the monitoring system to be informed in the stand-up, what do we need to do next in the sprint? And this all is about to get even further in this whole notion of self-driving IT. And we have here a component that we call Davis. And Davis would actively tell you where is a problem in the system, and there is one. And you can also ask Davis, based on artificial intelligence, what's going on in there. And to sum up, our DevOps manager is still also looking at that dashboard, for instance. It's all about now that the engineering team, kind of everyone lives DevOps. It's not just sort of this core team. Everyone lives it. And everyone lives and breathes, how are my customers doing? Lives and breathes it through the information of the feedback. And this is also why monitoring is always key in that, whether it's log or dashboards, whatever you use. And this brings me just to the final words and food for thought. Where are you now in your maturity towards DevOps, or maybe even NoOps with self-healing? How do you get your feedback that you need in order to change culture, in order to understand how your users are doing and kind of take on responsibility by your engineers, architects, and the entire team? And then also, of course, finally, sort of, if you love technology, if you love cloud, if you love AI, and want to have fun building great stuff, there's also the ability to think about working and joining our Gdansk team here. Thank you very much. Great seeing you.